In today's lesson, we're going to take a look at fractions that have variables in the denominator. Suppose we have an equation, y equals 2x plus 1 over x minus 4. I put that equation into the graphing calculator, and I get a table of values. Let's see what this table tells us. When I put a 1 into the function, I get out a negative 1. So whenever I plug 1 in for my x's, the result is negative 1. If I plug a 2 into the x's, the result is negative 2.5. If I put a 3 in, the result is negative 7. I'm simply plugging numbers in and finding out what the result is. But look what happens when I plug 4 in there. The calculator tells me it's undefined, or there's an error. Why exactly does it do this? Well, let's just take a look at the equation that we have. Y equals 2x minus 1 over x minus 4. And let's plug in the number 4. When I do that, the resulting equation is 7 over 0. And we know that we can't divide by 0. It just can't happen. It's impossible. It's undefined. And so because the resulting fraction makes no sense, we say that this expression, or this equation, is undefined when x equals 4. It's the value that didn't work. How can we find this simplistically? Well, really, all you have to do is look at the original function. And actually, all you really have to look at is the denominator. X minus 4 is where the problem can occur. We want to know, where does x minus 4 create a 0 in the denominator? So we simply say x minus 4 equals 0, and we solve that equation. We end up with x equals 4, which means that this is undefined when x equals 4. So go ahead, you can plug any number you want into this equation and it'll give you an answer out. But if you try to plug 4 in, it's not going to work. The machine's broken. It's completely undefined. It doesn't know what to do with it. Today we're going to take a look at several examples involving these undefined values of fractions. We simply look at the denominator in each of them and then find where that would equal 0. In example 1, we have 1 over x minus 2. I'm concerned about the x minus 2, so I say, okay, x minus 2 equals 0. Solve the equation, and we get x equals 2. That means that I could plug any numbers into this equation that I want, and it'll give me an answer back. However, if I plug a 2 in, it ends up with 1 over 0, and that's undefined. It simply doesn't work. Example 2 is for you to try. Take a look at the denominator, x plus 6, and find out where that would be 0. Please pause the video here and try example 2. We have x plus 6 equals 0, which means x is negative 6. Therefore, the undefined value is negative 6. We would have 3 over negative 6 plus 6, 3 over 0, which causes it to be undefined. Example 5 is pretty much the same thing. We might have two binomials. We might have a variable in the numerator and a variable in the denominator, but all we care about is the denominator, the x minus 8. Please pause the video here and find the undefined values for example 5. Let's see how you did. All we care about is the denominator, x minus 8 equals 0. That tells us that our fraction is undefined whenever x equals 8. Sometimes we have things a little more complicated. Example 6, we have x squared minus 9. The good news is that you can use your factoring skills in order to solve these problems. All we have to do is factor the denominator, x plus 3, x minus 3. Then we'll write an equation for each factor. X plus 3 equals 0, x minus 3 equals 0. And that tells me where my undefined values are. My undefined values are when x equals negative 3 or x equals positive 3. Don't believe me? Go ahead and try it. Try plugging negative 3 into this expression. In the denominator, we have negative 3 squared, which is 9, minus 9. That's something divided by 0. Can't happen. How about if you plug a 3 in here? 3 squared, 9 minus 9. Once again, the denominator would become 0. And so we simply can plug any number we want into this expression except for negative 3 or positive 3. Example 7 is also for you to try. Please factor the denominator and then find the undefined values. Please pause the video here. When we factor, we have x plus 2 and x minus 2. That gives us our two equations, x plus 2 equals 0, x minus 2 equals 0, and I solve those to find my undefined values of negative 2 and positive 2. Example 8 is the same thing. The first thing we need to do is factor and then find the undefined values. Please pause the video here and try example number 8. When I factor the denominator, I have x times x minus 5. That gives me my two equations, x equals 0 and x minus 5 equals 0. I solve those and find out that my undefined values are when x equals 0 and when x equals 5. If I plug either of those numbers into this expression, I'll end up with 1 over 0. And of course, I can't divide by 0. Example 12, we're going to jump ahead a little bit for a moment, is another one for you to try. This time we have a trinomial in the denominator. Please factor that denominator and find the undefined values. Come on back as soon as you're finished. We factor the denominator at x minus 1 times x minus 1. We then set each of those factors equal to 0. X minus 1 equals 0, and x minus 1 equals 0. We solve and we get our undefined values. We solve our undefined values. We find out that when x equals 1, this will no longer work because we'll end up with 1 over 0. So you can plug any number you want into this expression except for the number 1. That's the only time it won't work. Now sometimes we have little things. Look at number 11, 2 over 3x. There's nothing really to factor. We just know that 3x cannot equal 0. We divide both sides by 3, x cannot equal 0. Because 3 times 0 is 0, that would give me 2 over 0, and I can never have 0 in the denominator. Example 9 seems like a very innocent expression, 5 over x squared plus 9. We do the same thing we always do. We look at the denominator, factor, and find out where it would become 0. X squared plus 9 equals 0, then x squared must equal negative 9. But wait a minute. I can't think of any number that when I square it I end up with negative 9. Any number squared is positive. There's no number squared that's going to equal negative 9, and so therefore there's no values that are going to cause this to be undefined, because the denominator can never become 0. Therefore, I say there are no undefined values. You can plug any number into this expression that you'd like to. One final example for today, we simply have 3x minus 6. Well, notice there is no fraction here at all. There's no denominator. The denominator is empty. And really, the only time we have a problem is if we have a denominator that has a variable in it. But if there's no denominator, there can't possibly be a problem, and so therefore, there are no undefined values. So when you're working with rational expressions, all you're really doing is looking for the values that could cause a problem. You look at the denominator, begin by factoring it out, and setting up small equations equal to 0. Find out what numbers would cause that denominator to be 0, and let's eliminate them. We'll list those as our undefined values. That's everything you need to know about finding undefined values of fractions or restricting the domains of rational expressions.